This is our presentation for our paper for the optimal selection of a franchisee using temporal intuitionistic fuzzy pairs. So first of all, I want to acknowledge that this publication is sponsored by the project titled Index Matrices as a Tool for Knowledge Extraction of the Sales Zlotarov University. Now, franchising is a very effective business strategy that a lot of businesses implement. So, of course, the question to select the optimal candidate or franchise is very important. In some of our previous works, we introduced optimal interval value intuitionistic fuzzy multi-criteria decision making for selecting an outsourcer. And we also developed a software utility to solve this problem. The aim of this paper is to expand the approach we used in our previous publications to solve the problem of selecting a franchisee. As in the previous paper, my co-author presented about an hour ago, we'll use the apparatuses of index matrices and temporal intuitionistic fuzzy pairs. Here you can see some of the basic operations. The difference between a regular intuitionistic fuzzy pair and a temporal intuitionistic fuzzy pair is that here each pair has an added value that is a time moment. So yes, the problem here is that some large business wants to select a company that will be its franchisee in some region. And each candidate is evaluated using several criteria. Each criteria has a priority. And every candidate is evaluated on every criteria. The experts assess each candidate, and each assessment is an intuitionistic fuzzy pair, and the assessments are valid for a specific time moment TF. Okay. The final goal is to select the most eligible franchisee based on the results that are calculated through the algorithm, which we'll see right now. So here we have the initial evaluation matrix. Each expert will have their own matrix with intuitionistic fuzzy evaluations for each candidate on each criteria. Then we use the alpha T aggregation operation to find the aggregated evaluation of the DS expert. And then finally, for this step, we create the aggregated temporal intuitionistic fuzzy index matrix CV with the evaluations of all experts for all candidates. Then we continue to step 2. Calculate the index matrix V. Then we calculate the index matrix CV, which contains the final score of each franchise candidate for the specific time moment. Then we get the total assessment of each candidate using aggregation over the index matrix CV that we calculated previously. We can use one of 3 aggregations, pessimistic, optimistic, and average, which my colleague presented this presentation, which in effect will give us the best candidate in an optimistic, a pessimistic, or an average scenario. The next step is we import the matrix of the weight coefficient for each criteria. And then we use that to calculate the matrix B, which contains the total estimates for every candidate. And then using this matrix B, we will choose the most optimal franchise candidate by aggregating the results using one of the 3 aggregations which we spoke about. After we select the most effective franchisee for our time moment, we need to optimize the procedure for the next iteration. That is, if we need to repeat the evaluation at another time moment, we can optimize the procedure. So first, we use the inter-criteria analysis method to reduce the evaluation system by eliminating criteria that correlate with other criteria, therefore are not necessary for the next evaluation, because both criteria give almost equivalent results. So in inter-criteria analysis, criteria can either be in consonance, in positive consonance, negative consonance, or dissonance. And inter-criteria analysis uses the relationships between values based on the less than, greater than, or equal relations between them. So the values are not used directly, just the relationship between them for each criteria. And step 6, we calculate the new rankings for the experts based on whether they have decided correctly for this iteration. And these new rankings will be used for the next time moment when we repeat the analysis. And for example, if an expert has decided badly on this time moment, you will have a lesser rating for the next one. So the software program for this analysis was developed for some of our previous works. We used it for the IFMO and the IFMO algorithms, which were related to selecting an outsourcer. These tools can be used with Intuitionistic fuzzy pairs and intervals, as well as interval valued Intuitionistic fuzzy pairs. For the following example, we will use regular Intuitionistic fuzzy pairs without intervals. So if intervals are used, we must specify the minimum and maximum mark that an expert can give. If not, then that's not needed. In any case, we need to provide 3 files: the expert evaluations, the expert ratings that we have, for example, the previous time moment, and the weight coefficients for the criteria. So, for example, here is an evaluation of the example data used, which I will show presentation doing this, and you'll get the B matrix and the 3 versions of the aggregation of the B matrix. Now, to see what this means, the example is applying the algorithm over a large fast food restaurant chain, which evaluates franchisees over these 4 criteria: profitability and business experience level, brand marketing and franchise brand development concept, opportunities to quickly start a franchise, and restaurant traffic management and parking options, strategic locations, etc. These are 4 criteria. So first we have this matrix, which is a 3-dimensional matrix where every layer represents an expert. D1, D2, and D3 are the experts. And every expert is given a separate evaluation for each candidate over each criteria. These are the ratings of the experts. So calculate the V matrix by the aggregation. And here we have the aggregated value for each applicant based on all the experts in this case. Okay. We have selected one of the aggregations. These are in the matrix PK, we have the weight coefficients for the criteria. And using those and the previous matrices, we calculate the matrix B. And using this matrix, we can decide which of the candidates is optimal. So depending on how we aggregate, we will select one of the 3 candidates. In this case, it turns out that if we use the optimistic aggregation, we'll select candidate K3. If we use optimistic, if we use the pessimistic aggregation, we'll select K1, and in the average case, we'll select K2. So then we can apply the intercriteria analysis to select, to see if any of the criteria are in consonance. And we can see that C3 and C1 example shows some consonants, as well as C3 and C4. Yes, other ones don't show such a high consonants, but in any case, it's not very high. For example, we don't have a value of membership that is greater than 0.7 or 0.8 even, so very high. And finally, we use the formulas that were listed before to calculate the new coefficients of the experts, which will be used the next time moment. Let's say that they select new franchisees, I don't know, every several years, and the next period we will know which expert was better than the others. To conclude, we have applied our algorithm based on temporal intuitionistic fuzzy logic to select the best franchisee for a franchisor company. We used our software to calculate the results. In the future, we can expand our software to analyze further data. And also we can test examples that use multiple time moments instead of just one. So I think this is it. So thank you for the attention. And if there are any questions,
Very much.
my
Thank you
colleague
very much for your presentation.